Okay, today we're talking about 1.2, which is properties of real numbers. So we want to be able to classify the numbers and use properties to evaluate expressions. So the first one we have is natural numbers. Natural numbers are your general counting numbers. So when you count, you go 1, 2, 3, 4, and so on. Whenever you see this, that means that the pattern is going to continue. And natural numbers, they use a symbol that is a capital N, and it's almost like it has two lines that make up that middle part of the N. So it looks like that. Next we have whole numbers. Whole numbers are all the natural numbers, and now we have 0 on there. So 0, 1, 2, 3, and so on. And those use a capital W, and the two spots in the middle are thicker. Okay, so it looks kind of like that. Integers are now all the positive and negative versions of your whole numbers. So -2, -1, 0, +1, +2, and so on in both directions. And integers actually use a capital Z, like this. Rational numbers is next. Rational numbers are going to be anything that can be expressed as a fraction or a decimal that repeats or terminates. So I'm going to say fraction or decimal. Repeats or stops. Terminates means stops. So examples of these would be like 3/4 or 0.3 repeating, which is 1/3. Or 2.56, anything like that. Even the number 1 would be a rational number because that could be written as a fraction, 1/1. So the symbol for this is a Q. It's a capital Q that has thickness on the sides there. Okay, next we have irrational numbers. Irrational numbers would be anything that can't be expressed in a fraction. So like the square root of 2, if you type that into the calculator, that's going to give you a decimal that goes on forever and never stops. Pi would be another example of that. And irrational numbers sadly don't get a symbol. They're left out. But all of these numbers that we're going to talk about are all considered real numbers. So every single one of these that we've looked at are all real numbers. And that looks like this. It's a capital R with 2 bars on the side of it there. Okay, next we have some properties. So we have the commutative property first. So the commutative property works for addition and multiplication. So if I put an example in here that's like A plus B equals B plus A. And if I use like actual numbers here, 3 times 2 is the same thing as 2 times 3. It doesn't work with subtraction or division, because if you do 3 minus 2, it's not the same thing as 2 minus 3. Also with division. So these only work for addition and multiplication. The associative property is when you're grouping things together. So if I had 3 plus 2 plus 4, that's the same thing as 3 plus 2 plus 4. So all I did was change the groupings there, and that works for multiplication as well. So I have A times B times C in parentheses, or A times B in parentheses and then the C. It's going to give you the same thing no matter what. The identity, we have an additive identity and a multiplicative identity. So the identity for addition is what number can you add on to anything and it doesn't change the identity of that number. So with addition, you can add 0 on anything and it doesn't change it at all. And with multiplication, the multiplicative identity is what number do you multiply by so that it doesn't change it at all. That would be 1. Right? Multiplying by 1 doesn't do anything to the value. Inverse is going to be the opposite sign on here. So if I look at like the additive inverse, sorry, it's not going to be opposite sign here, my bad, erase that. It's going to be opposite sign here. So like 3 and -3 would be inverses of each other through addition. Because if you do 3 plus -3, that's going to get you to the identity, which was 0. Inverse of multiplication is going to be the reciprocal. So if I have 1/3, the reciprocal of that is 3 over 1. If you multiply these, 1/3 times 3, it takes you back to the identity. That's what the inverse is for. Okay. And then lastly, we have the distributive property on here. So the distributive property shows that we have, if we want to do an example for addition, I could say A times B plus C is equal to AB plus AC. So you're distributing this to both of those. It's really common to forget to send it out to that last one there. Okay. Example 1, we have name the sets of numbers that this number would belong to. So square root of 6, if I go up to this list, that would be a irrational number. And then all irrational numbers are real numbers. So I'm going to say irrational and real. The number 5, if I look back at these, number 5 falls into the natural numbers. And then all the natural numbers are also whole numbers, which are also integers, which are also rational numbers, which are also real numbers. So this is kind of the oddball here. But these kind of go like this, where they all connect to each other. So 5, since it's one of our counting numbers, that's going to be a natural number. It's a whole number. It is an integer. It is a rational number. And it's a real number. It would fall under all of those. And then part C, -2/3. So -2/3, since it is a fraction, that would be a rational number. And it's a real number. So all of these that we're talking about are all going to be real numbers. So you don't really have to worry about, they should pretty much always have that capital R on there. Okay, example 2 says find the additive inverse and multiplicative inverse of -7. So additive inverse means we want to take it back to the identity, which was 0. So what do you add on to -7 to get 0? That would be +7. Multiplicative inverse, what do you multiply it by to get back to a 1? That would be the reciprocal, so that would be -1/7. Okay, example 3 says Audrey buys 5 apps that are $1.99 each, 3 songs that are 99 cents each, and downloads 2 free apps. What is the total amount that she spent? So we have 5 times the $1.99 and 3 times 99 cents a piece. You want to do your multiplication first and then your addition, or you can just type the whole thing into the calculator at once. So this would be $12.92. And they put this part in there just to try to goof you up and see if you felt the need to put that in there anywhere. It's a 2. And last one, we're practicing the distributive property here. So I'm going to distribute that 4 to both of those. So this is going to become 12a minus 4b. This is going to get distributed as well. And then I'm going to combine like terms, so my a's can go together. 12 plus 6 would be 18. And then my b terms can go together. So -4 plus 2 would be -2b. So we did the distributive property. I kind of rearranged them, which would be the commutative property, grouped them together, associative property, and whatnot. Okay, so your last two are for you to do on your own. And for your joke of the day, what is it called when you steal someone's coffee? It's a mugging. All right, hope you have a lovely day, and make sure that you're nice to someone today.